welcome to a new unit. I'm so very excited. We are starting rational functions. Now remember from rational exponents that those had to do with exponents that were fractions. Well, rational functions are functions that are fractions. We'll get to that more in a minute. Go ahead and start by writing down your topic, multiplying and dividing rational functions. And the essential question, I want you to think about this the whole time. How can I simplify rational expressions? Over here, notice our key words. You need to know what these are so that you can follow along. Look them up if you don't, or I will help you along. We're going to do a couple things. We're going to do a factoring review. We're going to define rational expression. And then we will do 4 examples. So, let's get going. There are multiple ways to factor. There's greatest common factor. There are, sum and difference of squares. However, we're going to go over the most commonly used, and that would just be using factoring of trinomials. Now, I'm going to go ahead and give you the reminder. If a equals 1, parentheses done, and then on the other hand, if a does not equal 1, a being the coefficient of the squared term, if a does not equal 1, then you're going to divide or slide. Now, there is also grouping that can help resolve this. You don't need to divide or slide. However, that's sort of the shortcut that we have learned and that we're going to use. So here, we have a trinomial. A is the coefficient of the x squared term. So we have a equals 1. B is the coefficient of the x term, so b is negative 4. And c is the constant, so is negative 12. Now, there are a lot of different ways to organize your brainstorming, which is essentially what we're going to do next. Some people do boxes, some people do a big X. I'll go ahead and do a big X. I'm also going to do a little bit of a T-chart, right? So here we have A times C and then B. We need something that multiplies to A times C, little multiplication asterisk, and something that adds to B. Or you can think of it as a T-chart. Multiplies to A times C, adds to B. These are just a couple different ways, as I said, to organize your brainstorming. So A times C is 1 times negative 12, so that's negative 12. B is negative 4. So you can also write that in this way of organizing. You don't need to do both, right? Just pick the one that you like the best. I like T-charts though because I like having space to do my brainstorming. So factors of negative 12, things that multiply to that, would be negative 12 and 1. But those add up to negative 11, negative 6 and 2. That does give me my negative 4. Sometimes it might take you longer, sometimes it might take you less time. If you're doing the big X, you would pop those in here. What I often do, however, is just give myself some parentheses and I plop them in. So I have my x minus 6 and then my x plus 2. Then I double check, a equals 1, so parentheses, didn't write the second word, parentheses done, because rhymes help us all remember. And we are good. Now, just a quick reminder, a way that you can double check yourself is by multiplying your factors back out. If you factor correctly, then you multiply back correctly and you can go back and forth between these two things. So, one way to organize your double checking is with the box method. Once again, this is just a way of organizing to make sure you don't forget anything. So x times x is x squared, x times 2 is 2x, negative 6 times x, and 2 times negative 6, which gives us x squared plus 2x minus 6x minus 12, which if we simplify this, that becomes negative 4x, which is indeed what we started out with, so we can feel confident that this is the right answer. Now we're going to do an example from when a does not equal 1. We'll give ourselves a little bit more space. Starting to see the shark fin. You know something's coming up, but you may not know what it is yet. Alright, so here, just to lay it out for you, a equals 2, b equals negative 5, c c, the constant, equals -3. And then we're going to go ahead and I'm going to just use the t-chart this time. So what are two numbers that multiply to a times c and add to b? So multiplying and adding. Okay, so multiplying to a times c, which is in this case -6, and adding to a -5. So -6 factors -6 and 1, that actually is the correct one already. But, you know, if you had tried a couple other things, -2 and 3, you would add them together and you go until you find the one that works, right? So that's what I mean by brainstorming, because you have to try a couple things to see which one works. Okay, so I have my parentheses, they're waiting to be filled. So I'm going to use my -6 and my 1, x minus 6, x plus 1. However, since a does not equal to 1, I'm going to divide or slide. Let me separate those. Those are not the same thing. Separate. Okay, so we have our a value is 2, so we're going to divide or slide this 2. Now, how do we know whether we divide or slide? Well, if this divides into a whole number, not a fraction, then we just keep it. So 6 does divide by 2 evenly, so that's x minus 3. And this does not, though. That gives us a fraction, so we're going to slide it to the front. So this is going to be 2x plus 1. Once again, you can double check your work by multiplying it out, just like we did for this first one. I have already done so, so I'm going to go ahead and just box it. Okay, so that was our mini factoring review. If you need to review factoring, because you will be using it all the time, then find another video, find one of our videos, or look it up in some way, but make sure that you feel comfortable with factoring, because I'm not going to be spending a lot of time going over this anymore. This was a review. Okay, so we saw a shark, we saw something's coming up next, so let's take a look. So this is a definition of a rational expression. In a way you can call it a polynomial divided by a polynomial. And to simplify that down even more, it's when you have something divided by something with a variable, right? So we've seen fractions before. So a normal fraction, it doesn't necessarily matter, right? It can be a 3 over a 2, it can be a 5 over a 7, etc. However, in order for it to be a rational expression, we need to have some number. Actually, let me label this. This is going to be a rational function. We need to have a number over something that includes a variable like x. So 3 over x, or 29x plus 2 over y. It can come in all sorts of complexities and levels, but something divided by a variable. That's what we have there. Now, we need to talk a little bit about restrictions. Okay, so we'll talk about what it is and how we can find it. So a restriction is a value of x that would make the denominator 0, and it would therefore make the function undefined. So a restriction is the value of x that is not in the domain. Okay, it's an input value that doesn't work. How do we find it? How do we find? You set the denominator equal to 0. And solve for x. say x, it could be solving for y or whatever other variable it is, but you solve for the variables. Every value of x or every variable that equals the denominator to 0, that is a restriction. So, as we go through these, which we have our examples that we're going to start now, we are going to make sure that we factor first. We're going to do restrictions. And we're going to cancel. Now sometimes we have to do restrictions a little bit here, a little bit there. So you'll see that, but you just need to make sure that you do the restrictions. Okay, as I mentioned, I'm not going to spend a long time going over the factoring for these because that is a review topic. So I need to factor this. I know that numbers that multiply to -3 and add to -2 are going to be x minus 3 and x plus 1. So I'm going to replace this standard form with the factored form. The factored form is the more useful in this case. Now numbers that multiply to 5 and add to 6, that's going to be x plus 5 and x plus 1. And then we're going to start, well, either canceling or restrictions. I usually get so excited at this point where I start canceling, but then I have to go back and make sure I get all the restrictions that are necessary. So I'll go ahead and show you. Canceling, you cancel top to bottom. So we have an x plus 1 on top and x plus 1 on bottom. We cancel. You have to cancel a parentheses at a time. You can't just pick and choose random variables and numbers. You must cancel a parentheses at a time. The same parentheses or group, top and bottom. Okay, now we can't actually forget our restrictions. So I'm going to go ahead and say everything in the denominator needs to be a restriction, whether or not it was canceled. So that means I'm going to set this equal to 0, x plus 5 equal to 0, and I'm also going to set x plus 1 equals to 0. Then remember you solve for x. So that's x equals -5 and x equals -1. So I'm going to go ahead and write that down here. X equals -5 and -1. Those are the problems, so sometimes I go ahead to remind myself those are the problems. I say, x cannot be those. The domain does not include those values. Now we haven't actually simplified this, we crossed things off, but we need to draw all neat and tidy. So what we're left on top is x minus 3, and on bottom we have x plus 5, and there is nothing else that can simplify, because remember you have to cancel your parentheses by parentheses. Okay, so next example. As you can see, this one just has more going on. We have a little multiplication in the middle. Anytime you have a multiplication like that, you can essentially just make it one fraction, and everything in the numerator is all going to be multiplied by each other. Same thing with the denominator. Now, we don't actually want to start combining numerators and denominators until we've canceled out every single thing possible. So, let's start factoring. 2x minus 2, that has a GCF, a greatest common factor of 2. So I take out the 2, 2x divided by 2 is just x, -2 divided by 2 is -1. X squared minus 16, that is a difference of squares. So this is, I said I wouldn't do any factoring review, but I'll do a little bit. X times x, and -16 is -4 times 4. Whenever you have those, you can do x plus 4, x minus 4. Then here, this is just an x plus 4. This is a trinomial. Let's see, positive 2, -3. So that's going to be x minus 2, x minus 1. -2 and -1 multiply to positive 2, and they add to -3. Then we start canceling. Now I know we need to do restrictions, but I like to do those at the end. Just don't forget them. Okay, so you cancel top to bottom, parentheses by parentheses. So 2, there's no 2's. X minus 1, I do have cancellations for that. X plus 4, X plus 4. X minus 4, no. X minus 2, no. So those are the things that get to stay behind. We have a 2. We have an X minus 4. We have an X minus 2. Do you need to distribute this back out? No, I don't really care. Now, let's talk about our restrictions again. So, anything that has been in the denominator. So, that means that this and this, all the denominators. So, we have X plus 4 equals to 0, X minus 2 equals to 0, and we have X minus 1 equals to 0. Because remember, we want to see what value of X makes this equal to 0, right? This is our question mark. So we use our solving skills that we've practiced for many a year. We subtract 4 from both sides. We get X equals negative 4, X equals positive 2, and X equals positive 1. Those are all restrictions. So I'm going to write them down here. Negative 4, 1, 2. I'm so fancy, I put them in ascending order. Okay, these cannot be part of the domain. The domain is all real numbers except for these shenanigans. So, all together, your answer must include both this and this. Now, this next one is division, and this is where I have this little note here. Restrictions are anything that has ever been in the denominator. Okay, so as you're taking these notes, think about ways that you can abbreviate but still understand, right? So if you want, you can just write restrictions, anything ever in denominator, right? So if this is too long for you to write, shorten it up. Restrictions, anything ever in the denominator. So you don't even need to write the. However, it helps you remember it though. Okay, so trinomial, trinomial, binomial, binomial. So I'm going to go ahead and factor everything out, and then I'm going to flip. So this is going to be a minus 4 plus 2. Y'all, you just get better at factoring. You just have to keep going, right? Don't give up. You will learn. It will become like a reflex. So 2x is the greatest common factor. 2x squared divided by 2x is just x. Negative 8x divided by 2x is negative 4. And here, negative 15, negative 2, so x minus 5. X plus 3, and this is also greatest common factor, 2x, x, 5. Okay? Alright, so we have all these shenanigans. Now, I do want to once again draw your attention to that little negative symbol in the middle. So, whenever we are dividing, you can think of that as multiplying by the reciprocal, right? What do I mean by that? What I mean is that, say we have the number 6, dividing by 2, or 2 over 1, is the same as multiplying by the reciprocal, so 1 over 2. These are the same. So, we're going to use that same process here because it's easy enough for our brains to comprehend this. They're just normal numbers. But trying to comprehend the variables involved with this is problematic. So, we're going to use this idea of dividing by a number is the same as multiplying by its reciprocal. And we have a handy little way to remember that. We do K for keep, C for change, and F for flip. Okay, so just like here we keep the 6, we change the division to multiplication, and then we flip the last part. So we're going to do the same thing over here. So we're going to keep this one. So it's our x minus 4, x plus 2, and our x minus 5, x plus 3. Some of you may like just rewriting anyway because this shenanigan may seem like too much all at once for you. So we keep, then we change this to multiplication, and then we flip. We do the reciprocal. So flip this over, we have a 2x times x minus 5 is now on the top, and 2x times x minus 4 is now on the bottom. Now, we've got it all set up to just cancel like normal. Okay, so top to bottom, we have an x minus 4, and all the way over here we have one, so cancel those. Then we have an x plus 2. That looks like it's going to stay. 2x, 2x, x minus 5, x minus 5. So we are left with an x plus 2 over an x plus 3. Now remember, restrictions are anything that has ever been in the denominator. So let's see all the things that have been in the denominator. This has, and also this has. So we're going to list them all out, but there will be some redundancies, meaning you'll see some things happening twice that we don't need. So I'll just start listing them over here. So restrictions. Okay, so we have x minus 5 equals 0 from here, x plus 3 equals 0 from here. We have 2x equals 0 from there. We have x minus 5 equals 0. Okay, we don't need this again because it's the same thing in there, so I'm just going to kind of cross that. We have, down here we have a 2x equals 0. Once again, we don't need that one. We have an x minus 4 equals 0. It is better to calculate something twice, however, than to forget anything. So don't skimp on finding your restrictions. Okay, so this would be x equals 5, x equals negative 3. This, okay, if you think about this, I'm dividing both sides by 2, right? Divide by 2, divide by 2. This cancels, so I have x equals, and then 0 divided by 2 is just 0. These we don't need. This I add 4 to both sides, so x equals positive 4. And these are all my restrictions. So many. So x, I'm going to be fancy again, put them in ascending order, meaning smallest numbers to largest. Hoo-hoo. And this means that the domain cannot include these values. So your final answer is both this plus this. Also, since there's a lot going on with these, pay attention to where your teacher is asking you to put your answers, because you don't want her thinking that this is your final answer when it's actually over here, right? So be careful with that, just so it will make your life easier. Okay, so looking at this, example 6 and 7, if you're at the RHS on level Algebra 2 community, then your teacher's going to go over that. I will also make another video to do these later just in case you missed class. But right now we're going to skip those and we're going to go to example 8, which has something a little bit different. So one thing that's special about this one is it is a rational function, just like we've been learning about. But we get to do a little review, or rather we get to use these happy properties of exponents that we spent some time learning. Yay! So, let's zoom in a little bit. Okay, so here, there's just a lot of canceling going on, and bear with me as I go through it all. So, I'm going to start by just comparing this 12 and this 6. Remember, normal numbers divide like normal numbers, right? It's the greatest common factor. These can both be divided by 6. which gives me 12 divided by 6 is a 2, and 6 divided by 6 is just 1. I'm not going to write the 1, but you know it's there. Okay, here I've got x to the 5th power and x squared. Okay, so remember, either when you're dividing, you can think of it as subtracting the powers. So we get nx cubed up top. Or you could think of it, oh, that's a little hard to read, that is a cubed. Or, and this is a 5, just to make that clearer. Or you can think of it, there we go, that's a bit better. You can think of it as a playoff between these two values. So this is the game X, numerator against denominator. Numerator got 5 points, denominator got 2 points. Numerator wins, and it won by 3 points. Okay, same thing here. Y squared versus y to the 4th. Denominator wins, so our y is down here, and it won by 2 points. Okay, we've got a 9 and a 3 we're comparing. Those can both divide by 3. I'm not going to write 1, but I am going to write 3. We've got x cubed and x squared. Well, team numerator won, and they won by just 1 point. So x to the 1st power, remember, is just x. But I wrote the power just in case. Now y, remember, y is y to the 1st power. So team denominator wins this playoff. So that goes away. Denominator 3 to 1, so they won by 2 points. So let's go ahead and rewrite this so it's a little bit neater. 2x cubed times 3x y squared times y squared. Once again, using our properties of exponents, don't you love them? So our normal numbers multiply together like normal numbers, so 2 times 3 is 6. Now x cubed times x. When you multiply exponents, you add their powers. So that's a 3, this is an invisible 1. So 3 plus 1, you get x to the 4th. And then here we have multiplying. When you multiply exponents with the same base, you add the powers. That's a multiplication symbol. So 2 plus 2 is 4. So we have y to the 4th. So that is our answer there. Now, let's talk about restrictions. Here, they look slightly different. So things that have been in the denominator. Okay, all that has and all that has. So 6 is in the denominator. But y'all, plain numbers can never equal 0, so we can kind of just ignore that. We just really want to look at the variables. So x squared equals 0, y to the 4th equals 0, and one thing that's fun about this is that whenever we have just a pure variable by itself, we don't have like x plus 4 or whatnot, that just tells you if that variable equals 0, that equals 0. It doesn't matter what power it's to, actually. Just that variable, if it's not being added or subtracted in a little parentheses, that is just going to be 0 is the problem. Likewise, 3 can never equal 0. We have an x squared again, but we don't care again because we already know x can't be equal 0. We have a y cubed. While that is a different power, like I said, the powers don't matter. If it's just a variable without being added or subtracted in the parentheses, then it's still going to give us that. So the restrictions for this one is that x cannot equal 0 and y cannot equal 0. Super fun! So sometimes you're going to have things that have multiple variables, sometimes you won't. That's what makes life so exciting. Okay, as I mentioned, look ahead to find where and when. We will do examples 6 and 7. Make sure that you write things down. Go back and rewind and pause to write all this down so that you have these notes, so that you can see the steps one by one from the original problem to how we solved it. Write down any questions you have, think of new questions, and we'll talk to you later.